Hello out there, internet world. The internet is not a real place. Remember that. I'm Chris Miller, and the owner of Pure Drivetrain Solutions. Also, which is a part of a bunch of other brands that some may know me from, some may not. 99% of the people watching this video are going to be Pure Drivetrain Solution customers, future customers, whatever it may be. But for the other ones that don't know who we are or what we do, we have a bunch of other brands that operate at the pinnacle of their arenas. Bonafide Friction is one of them. If you don't know who that is, who we are, it is the top friction and disc floater company in the world. If you've ever watched an HRA, top fuel for any car or pro stock, 100% of the market, all over the world. So that's one. Then you have Pro Torque and Precision Industries based out of Tennessee. Same thing, we do a lot of diesel converters through Precision. On the Pro Torque side, a lot of drag race stuff, X275, X275, Pro Mod, LDR, streetcar stuff. If you don't know the Pro Torque name, you've been under a rock.
I've been living under a rock. Now tell me.
As far as the other brands, there's Ultralight, which is based out of Pittsburgh. It is a brake manufacturing facility. It is 100% private label. We manufacture mostly rotors and hats. We do some pistons, some caliper stuff, but it is 100% at this point a white box company. We get prints or we help engineer the parts, manufacture it, and send it out. Then there's Kenny's Pulling, which is out of Kentucky, does obviously pulling trucks and big diesel clutches, bell housings, things of such. And then you have the smaller companies like Jay's Composites and Neverlift Production, CMR Productions, and there's a few others that are in the mix that just don't need to be touched upon. Just want to give a quick introduction to people who don't know who I am or where I come from. That's a quick background of me and the team. We have multiple locations in New York. This building is a little over 30,000 square feet. That's just the ground level, but most of it is 2 stories. So actual square footage, I don't know. We have a second facility here in New York, which is where the composite company is. And then you have Pittsburgh, Philadelphia, Tennessee, and Kentucky. We have right around 100 spindles online each day. And when I say that, it's called 100 CNC machines online every day, manufacturing parts, right around 150 employees. None of the brands do we settle for anything but the best. We are continuously striving for perfection, and that's from the manufacturing to the sales and distribution to the marketing to every single part of running the business. It's a challenge, and we love attacking it every single day. So that's a quick overview of who I am on the business side and who we are collectively as a team. We all have a very diverse backgrounds. I tuned for a very long time. I ghost tuned for even longer, from all sorts of platforms. BMW platform, which is what we're going to talk about today. We're going to take it over into Unit 4 and kitting and show you some of the transfer case stuff and things we've done over the last 5 years, and we'll take in the QC room and show you some of the stuff, the development that we've done along the lines with the 8HP transmission. But that same development that we're going to show you today on the 8HP, we're doing for the 8L90 and for the 10L80 and the 10L90. We have a lot of irons in the fire right now, and we're developing some really cool stuff, some next level stuff that we're all really excited about. Biggest thing that we see on the BMW platform is that people just don't understand is there's no real transmission tuning. Nobody. I don't care who you are, what you're doing, you're kind of just guessing at this point, to be honest. There is no data log. Nobody can give you a data log of your crossover pressures, of your shift, nothing. It's not even available to anybody. So anybody who's saying that they're tuning a transmission or whatever, yeah, they might have figured some things out. They, went in and figured out the code. They know what this is. They know what that is. They know it, but they don't know what they're actually doing. XHP seems to have the best handle on it for the BMW stuff. I know the guy out of the UK, Mike, he's doing a decent job with stuff, and he's figured some things out. But at the end of the day, if you can't provide a data log to a tuner, and then he can dissect it and give you back based off of your data changes, you're just guessing. So I mean, this would be the equivalent of, and for anybody out there who's a tuner or you want to be tuners who own a laptop, this would be the equivalent of loading up a base file into your car that you got from somebody and going out and making a poll. Go make your fucking 60 to 130, go make your 100 to 200, whatever the fuck you want to do. And then go back and make changes off of how it felt on the butt dial. No map sensor reading, no air temp sensor reading, no coolant pressure reading, no timing, nothing. You get no data. And now tell me how well that engine is going to possibly live or perform. That's what we're doing with the BMW platform. That's what these guys are doing, which is fucking mind-blowing. But then on the other side, you look at some of the Chevy and Ford tuners, and I use the term loosely on the tuner side, because a lot of these guys just don't understand torque-based modeling. They don't understand torque-based model tuning. They don't understand it. They don't understand transmission tuning. They just don't get it, and they're hacking shit up. And we've had many instances where guys are pointing the blame at us. All of a sudden, it's in a different tuner's hands, and all the issues go away. So it's a very hard for us to navigate with some of these things, especially with the egotistical fucking tuner mentality that we have to deal with. And for a lot of guys that didn't know that I tuned for a long time and that I ghost tuned for even longer, that when they're spewing bullshit to me, I know 90% of them are spewing bullshit. So these are areas where we've had issues, and we hope to move on from there. We roll into like the kits. So we sell an HPK kit for, we're doing ZF8 transmission. We sell you a kit for a ZF8 transmission. You put said transmission together, and these are the same parts that we use on our in-house builds. The same parts that we've got 8-second cars, 7-second cars running without issue. You go out and in 5 passes, 500 miles, whatever you want to call it, and you burn it up, and you bash us online, or you bash us in your little group chats, and you go, oh, their steels are this, and their frictions are this, and they're this or that, and they're this. That is the equivalent of buying a set of pistons. So you go off and you got your engine, and you want to be fucking Bob the Builder in your garage, build your engine, and you go buy a set of Arius pistons or CP or whatever, I don't care. You buy this piston, you put these pistons in your engine, and then you go out and you melt them all down, and you made piston soup. Now you're going to call them and bitch to them because you melted, because the pistons are melted. The pistons are junk. You melted the pistons. That's the same exact thing that you did to the clutches that we sold you. You didn't break a hard part. You didn't snap a hub. You smoked the friction on the steel. So either your air gap was wrong, you had a bad O-ring, there's tons of things. You didn't follow the break-in procedures. Your fluid wasn't right. There's so many variables that come into play. At this point, as of March 2025, we have built just right around, we're not exact sure the exact number, but right around 5,000 8HP units since the inception of our 8HP program. That's a lot of units. Like, it's a lot. From Dodge to Aston Martin to Lamborghini to the BMW, obviously, and Mopar, like 5,000 units is a lot of units. So I would say we know the 8HP better than anybody else in the market. And I say that pretty comfortably. So let's go over to Unit 4. We'll talk about some transfer case stuff real quick. I'll show you what we've been doing for the last 4 years on the transfer case. Maybe give you a little insight on that. And then we're going to shoot into the QC room, and I'll show you some of the iterations and changes we've made over the past couple of years on the 8HP. And like I said, what we're going to show you here for the 8HP and for the BMW transfer cases is just a small part of those entire platforms, but not including new 10-speed stuff, new 8L stuff, the new 9-speed stuff, the new Toyota 10-speed. We have platforms, and we have a lot of DCT products that are vetted, tested, and ready for release that we have to get the manufacturing up to par, like as far as being able to produce the parts, not the quality, but just the time to make the parts. So yeah, let's shoot over to 4, and we'll give you guys a quick little intro on the transfer cases and what we do. We started building the BMW 13.1, 35L, 45L transfer cases in 2021. It started off with just a few here and there, and then the 35, 45Ls were pretty, guys would just buy them from junkyards and swap them in. Then the 13-1s in the G80s became a problem because you couldn't buy them from the dealer at the time as soon as the car came out. You couldn't buy service parts. You couldn't go on eBay and buy a clutch pack and steels. You couldn't buy the chain. You couldn't buy the plastic part kit. You couldn't buy anything. And then when they did finally come out through BMW, I think in 22, they were like $5,000 for a new unit. At first, we didn't know why they were burning up. It wasn't until later on that we learned on the programming side, like what settings to have the car in and then what not to do. Mainly, specifically, the dynoing the car in rear-wheel drive mode is what was burning them up. We burned up 2 on my personal car, just on a rear-wheel drive mainline, and didn't know why. So then we started the early iterations. We were using factory OE friction, which we sourced. BorgWarner is the manufacturer of them. They were not easy to get. We got them. The steels, we use OE steels, but then we would surface grind and time save them down to take roughly a thou off of each steel, a little bit more in some cases, get the surface finish to where we wanted with the time saver, and we were getting a little bit more air gap. We just thought that they weren't releasing, so they were dragging. So that was the very early iteration. Then the next iteration was still OE frictions, OE modified steels. Then we started heat flattening the steels. And when you heat flatten them, if you do it correctly, you bring the carbon in the steel to the top, which also raises the coefficient of friction of the pack at that point. Then we started machining the inside of the basket ever so slightly. I'd have to look back at our notes, but it was like, I think we were taking 5 or 10 thou out of the inside there, and then out of the base plate we were just giving it a fly cut. Just once again, opening up the air gap to stop it from dragging. So that seemed to work for a long time until I started getting into the big power. Then we started seeing burned up clutches, we started seeing chain stretch, we started seeing just weird things with the shaft. So wasn't much we could do about the shaft at the time. We haven't seen enough of the failure still to date to make a shaft or upgrade the shaft. We had shot peened some of the shafts and did a super finish on them, testing them. We didn't really see a difference. The biggest ones that we saw that had those issues of twisting the spline, we couldn't get the yoke off of the transfer case, was in Mikey's car in tennis ball. But he did that once. The next one we did for him, we shot peened and super finished the shaft, and that was it. Like I said, that was only a rare scenario that we haven't seen yet since then. So then in 23, we started doing a stock OE friction count, but with our own steel, a higher grade steel. It was also same thing, heat flattened, time saved to where we wanted. We didn't want to keep cutting the baskets. We did a couple small things with oil passages and things like that. On the shaft to the bearing, we loosened up the tolerance from the shaft to the bearing, just same way as you would do a crank journal, just put it on the lathe, take it down a little bit. Just a bunch of little things like that. And then once we started seeing guys over the 1,1400 horsepower, then we started to look at the heat in the friction in the steel and see what it was doing, and it looked like it was just overpowering it. So that's when we came up with the +2 HPK kit, and that was in, I believe, July or August of 24 that we finalized what we currently have now and sell for the 13-1 and the 3545L, which is a +2 friction. It's a high grade steel that is treated just like our other steels. It's heat flattened, time saved. The chains, we buy a brand new OEM chain and we run it through a heat treat process and then also a super finish. It just, once again, just one more step on what it is on the package. We include a new plastics kit. There's no need for anything more in that. That just channels the oil. New seals, upgraded bolts, and then new spring and base plate is what comes in the 13-1 kit. The 3545L pretty much went through the same steps. Once we started to see guys in the 13-14 plus range, we started to burn them up. Even well before that, we did the billet aluminum diverter valve. It's just 60-61. There's no load on it. There's no need for it to be anything exotic. Same thing. Really good steel, really good core, good friction. We made it all up with the pack. Same thing. We fresh set of bearings. Everything that when they come in and we build them in house, everything gets a soda blast, gets hot tank, goes into sonic washers, and that's kind of where we're at. It's just the progression. It's a natural progression of the product over time. So for 4 years, this has been step by step by step where we've gotten to today. So if you were to buy a used transfer case from somebody today, and yeah, we built it, okay, it could be any one of those changes. So if you're looking on the market and you're buying a used transfer case and you have a used transfer case or whatever, you can just send us your invoice number and we can tell you exactly which revision it was, when we built it, what was in it, what was done to it. And that's really about it as far as the transfer cases go. It's pretty simple. And it's just like I said, everything else. It's, you know, it's the equivalent of having an iPhone 16 today and then buying an iPhone 12 and saying, hey, this thing isn't the same. Yeah, they're both iPhones. Yeah, they're both Pro Maxes, but progression over time leads to a better product. And this is not going to be where we end. Like, we're going to keep developing it. We have a billet outer case that we worked on. There's other things that we've looked at with doing within this transfer case that we just need to test and vet out before we release it. But this here is the HPK kit that we use for our in-house builds and we sell for anybody who wants to buy it and do it themselves. I'm in the QC room, and same thing we did for the transfer case. I'll show you some of the things that were changed and upgraded over the years in the transmission build. As you can see, this was last week's work. Road transfer case transmissions. These are all, this is shipping and kitting room. So
We ain't going nowhere.
yeah, just waiting for people to pay their bills and get stuff out the door, but let's go into the QC room and I'll show you some of the stuff for the transmission. All right, so let's talk a little bit about transmission development now. Since the 8 HP is a hot topic, I should say right now, this is what we'll go into. So the 8 HP, once again, just like the transfer cases, if you go back almost 5 years ago when we started building them, a stage 1, when we first started building them, we only had a stage 1. It had a stock hub. We had a couple out there, probably a dozen or so, and Andre, one stock, broke the hub. Then I believe Visconti broke the hub. At this time, there was no hub. An e-hub did not exist. You couldn't go on eBay and buy a hub. You couldn't call your transmission supply house and get an upgraded hub. It just didn't exist. So once again, being at the forefront of it and getting ahead of the market, we developed a hub. So the first hub we designed, like these samples right here, this is just the 8 HP 5051 platform only. These samples that I'm going to show you right here. This is all these are. So the very first hub we did, steel hub, bronze bushing, brass bushing, pretty nice. We ended up learning some stuff that we didn't like the steel hub. Rotational mass was a big one. Clutch apply, de-apply times, things like that. Just the weight of it is too heavy. So then we went to an aluminum hub. I don't have any of them here. It was this exact design. So this is the same design as this, but it was a 6061 material. We tried heat treating it and doing different things to try and get it to live. It just wasn't happy. We started twisting splines. We didn't think we had a couple break, but once again, learning curve. So this is our Gen 1 design, 8 HP 5051 E-Hub, but this one's out of 7075. After the 6061, we went to the 7075, is what I should have said. Now, the 7075 lived, everything worked great. Once again, just doing as many as we've done at the time, which was a couple hundred, pretty quickly, we found some things that we wanted to change, and then we came up with what we call the Stage 3 hub. Now this is iteration 1 of the Stage 3 hub. Now, these hubs might look alike, but they're not. There's some oiling modifications, but the biggest thing here, the easiest way for me to show you is to flip this upside down and show you the difference in the overall spline height of that holds the clutches and steels. So what we did here is we raised this wall, and then in turn we cut the piston, and now we could get 2 more frictions and steels in there, which in turn increases the capacity. Now, all along this time, we are testing different frictions, different steels, making changes, and these are, I'm talking about, this is just E-Hub development on the 8HP51. Then we went to the Gen 2 design, which had scalloped oiling holes. We dropped the pad down a little bit more. We changed some oiling inside. Just same thing, just an improvement on this. Once again, now we're a lot of transmissions in. We're like, hey, we want to make some changes. This is where it went. Then, same thing. Gen 2, Stage 3 hub. Once again, this is, you can see the overall height difference in the spline. You got to cut the piston for it to work. This one, we went a little bit more radical with it as we dropped the floor. So we not only went up with it, we came down with this. And then in turn, you have to modify the top of the C-pack piston, which is below it, to clearance for this. And these are all things that we had to learn and spend a lot of time learning and figuring out. So when people say, oh, this guy made this guy, I don't give a fuck. Everybody who's building 8 HP E, C hubs, shafts has copied our shit. Plain and fucking simple. because I have the prints, I have the models, I have hundreds of test sample pieces. Now, you go into the Gen 3 stuff. The Gen 3 stuff, same thing, it's still a 70-75, a little bit different on the processes after. We changed some things with the landing pads here to keep that bottom plate a little cooler. It's really hard to tell versus the Gen 2. The Gen 2 to Gen 3, but you can probably see them there side by side. The differences on the landing pad, and some people just won't understand what that does, but it flows the oil out of the pack, and then also, you know, we place oiling holes in the outer baskets and do a lot of small things that if you don't know what you're looking at, you're not gonna have a clue as to what we're even doing. Once again, this is just one part in the transmission. So when you take it apart and you look at this and you go, oh, it's got a billet E-hub. Now you understand over the last 5 years how we ended up here. Only we can show you that. Nobody else can. I mean, look, the C-Cog drives in the 9095s, we broke a couple early on. Yeah, January 23. That was a QC part. These red tags failed QC testing. So once again, our pursuit of perfection is never gonna end. And if you wanna take apart something now and compare it to what we're offering now to what we offered in 21, 22, 23, even 24, or even early 25, there's going to constantly be changes. It's going to constantly be upgrades. We are never going to stop. We have so many new things still planned out for the 8HP platform. For instance, once again, the BMW platform, 14, 15, 1600 horsepower is nothing. We're going to see 1800, 2000 horsepower. And when we get there, we're going to be ready. Nobody else. This is just one part. That's just the E-hub. And we've spent the same amount of time on the C-Cog drives. We've spent the same amount of time on the C-hubs. Same thing. As many iterations of that has there's been for the C-hubs. Same thing, the Planetaries. So these Planetaries here, listen, I'm giving you guys all the secrets right now. We pop these apart, we change the pins, we put a tool steel pin in there, and when it's apart, underneath here, we weld, we reinforce it, we weld on this side, we weld this, we put it back together. The only trick to this, the hardest trick that we had to learn, was how to do it and not mess this up, because this is the speed sensor, which is all magnets. And if you don't know how to get this apart correctly, you're up shit's creek. So don't try welding on it with that in there. But that's how we do it and don't have issues. But it took us a long time to figure out what was going on. We were seeing gears move in, the covers treat. To make this out of billet would 2-3 times the cost. And for what reason? There's no reason. So this works. We have not broken one of these since we've modified it like that. And this is what's in 1800, 2000 horsepower Trackhawks that have 200 passes. So that's, once again, it's one more piece in the amount of iterations we took to get this right, with getting the right pins, getting the welding right, to getting a fixture that holds this straight while we weld it so nothing moves, welding on this other side, then getting it back together and not messing up the speed sensors has been a pretty good task. Shafts, a lot of people ask about shafts. So a couple of years ago, we were taking, people were breaking shafts. They were breaking them at the snout here. They're breaking them right here. There is a severe stress riser at the end of these splines where it comes into this O-ring area here, which needed to be addressed. And then there's also another one down on this end. This is a stock shaft. So before we made our billet shafts, what we would do was we would actually come in and hard weld on that area there, and then we'd hard weld on this area here, turn it down, try and give a little bit of strength there. Then the shafts, like this, would get shot peened and super finished. It increases the strength and takes out as many stress risers as we possibly could. The compressive layer of metal, the first layer is your important part that we're trying to help a little bit. And then the shafts all go onto the lathe, and each journal gets polished and mic'd and set. So this is what we use in the mid and small frame. So we do have billet shafts for everything from the 45, Gen 1 to the, we've modeled and made them all. The only one that really needs it that we've seen is the 9095s. We've had 2 small frames ever break an input shaft or transmission shaft, and 1 mid frame, and they were both on standalone TCMs. So we don't know if 2 gears were applied or whatever, but this is what we do. We buy a new OEM shaft, we fix that there, shot peen, super finish, and yeah, it's not the end all be all, but it's a great solution for a problem, and these do really, really well. After everything, they come back here, one of the guys will mic them up, each one gets serial numbered, they go down all the boards with the scope, make sure the plugs are all good, they bench test them, we have some fixtures to pressurize them and check them. This is another one that we're using for a small frame that is same process as that, but it has a different coating on it. It's for a road race application, or actually a time attack application. And same thing, we're modified some of the oiling holes, but we're trying to get the heat out of the shaft. So that's something else that we're testing with one of our guys. Then you come into, like I said, the billet shaft. So this right here is billet shaft. It's not 300M. I know I said 300M online, but I like watching people regurgitate bullshit that they don't know. This is much better than 300M. As you can see here, if you look at the radius here and you look at some of the radiuses along, the stress risers are taken out. If I put them side by side, maybe you can see it a little bit better and understand what we've done there. Anybody who understands will get it. Everybody else just won't, because they're fucking stupid. But this is our billet shafts that we run. So once again, this is standard in our Stage 3 9095s as of recent. We were using those originally. We had a lot of good luck with those. We do some of the shafts, we will just do the heat treat, then the shot peen. Most of them now, our most recent ones, reheat treat them, do the hard weld, heat treat, shot peen, super finish, and that's the shaft that goes out. That's what we're offering. Once again, for the small frame and the mid frame, is it needed right now on the BMW side? No, the cars just don't make enough torque to warrant it. A stock shaft is fine. I mean, I got a stock shaft in my car right now, just because we were testing stuff and there was spare trains together, and I just didn't want to waste parts on my own shit. So that's where we're at on shafts. And when the time does come for the small frame and mid frame to need a billet shaft, we're ready to go. We've already vetted out all of our material, all of our processes, all of our gun drilling. And once again, I've got models, prints, all the data. I could more than happy to show people the machining process on it, which we might actually start doing, just for educational purposes, so people can see what really goes into this, where we don't just buy it from Pure and send it to fucking Taiwan, China, India, and say, here, make me this. Or they take a stock shaft and send it off and have a copy, because you're not doing anything when you do that. It's the same thing. There's people selling billet parts that don't need to be billet. And I know that they're not actually billet, but you know, I put it in context like this to somebody the other day, somebody asked me, hey, do you have this in billet? And I said, no, why the hell would I have that in billet? And he's, well, I'm like, do you have a billet windage tray in your engine? And he's like, what? I'm like, do you have a billet windage tray in your engine? And he's like, why would I have a billet windage tray in my engine? Fucking exactly, it's a waste of money. People are forcing billet onto the end consumer to force it down their throat that they need all these billet parts. You don't. You just need some ingenuity and some fucking brains, and you can do things like we did with the Planetary that we know everybody's copying. We've been doing that for years now. And once again, these are just a couple of the parts within these builds that have been developed over the last 5 years. Now you've got 45s, 50, 51, 55, 65, 70, 75, 76, 90, 95, now the 100, and the 80. And there are small iterations of parts that are within it. We have over, I think we're over 700 SKUs on our inventory. You know, there's hundreds of thousands of frictions in Unit 5. We created this market. So, and I don't say that conceited, I say it because we did. Before we were here, before we were in this space, there was nobody else doing this. There was, if you had an 8HP 45 or an 8HP 50 in your BMW, you were limited to 550 horsepower, or you threw it out and you just got another one. Now, we came in, we created the market. We created revision after revision after revision after revision after revision, and we're not gonna fucking stop. We're gonna keep going. Why? Because we can. We're an engineering house. We have our own manufacturing facility in-house. We have our own development team. We are self-sustainable. End of fucking story.